We have another polynomial question, but this one is a bit more complicated. So let p of x be equal to ax to the fourth plus x cubed plus bx squared plus cx plus 168, where a, b, and c are real numbers. We're given that three of the roots of p of x are -2, 2, and 6, and we're tasked to find the absolute value of the other root of p of x. So note that in case the answer is negative, we're supposed to give the absolute value of that. Okay. Before I dive into the solution, I'm gonna introduce something first that maybe not many of you might know. This is Vieta's formulas. Here I'll show it for okay. Here I'll show it for degree 4, and then we can try to generalize it to an odd polynomial. So firstly, the sum of the I'll just show the sum and product. Okay. So the sum of the roots is is always equal to negative of the coefficient of this power. Hold on. Okay. Yeah, sum is here. Well, it's not b over a, but let's say we set this coefficient to like um, let's say p, then the sum of the roots is negative p over a, right? And then sum of pairwise products, just for completeness, products. Or basically, pairwise products means you pair each of the roots and then you multiply them and then you add all of those products. That is positive b over a. And then we go on and on doing alternating between negative and positive. So here, the last one, we will end with positive. So the last one is the product of the roots. It's 168 over a. Okay, question so far? Okay. If none, I'll continue. So here, let's use it with the roots that we have. Notice that the current roots that we know are -2, 2, and 6. We can let the other root be r. Then we have that removing this p here, since we know that it's 1. We have that -2 plus 2 plus 6 equals -1 over a. Basically, these two cancel, so 6 equals -1 over, oh no, plus r pala. So -2 plus 2 plus 6 plus r is -1 over a. If we rewrite this, we have 6a plus ar equals -1. And then we also do this for the products, -2, 2, and 6. And r equals, here we have 168 over a. Okay, so that is -2 times 2 times 6, that is -24. -24 r equals 168 over a. We can actually use this to get the value of ar, right? And so here we can get that ar equals -7. We can substitute it here. So 6a minus 7 equals -1. And solving for a, I won't show the steps anymore. We get that a equals 6. My bad. A equals 1. Right. So after all, the polynomial is mono. And from there, we get that the product of the roots is indeed 168, or we can use the sum here. Uh, but if we use the product, we can get that R is 168 over negative 2 times 2 times 6, right? And that gives us negative 7. And since we're asked for the absolute value, the answer here is 7. Questions? Okay. Okay. Yeah, this also a valid solution. The one in the chat. So essentially, this like system of equations, right? Substituting each root. I guess this one is feasible because I guess this one is fine because it's there are three unknown coefficients, but in practice, it takes kind of long. So better to just use betas. It saves a lot of time. Do we have questions before we move on?